The spring of 1945 brought the war in Europe to its final, chaotic weeks. As Allied armies converged on Berlin and the last pockets of German resistance crumbled, a quiet crisis unfolded along the communication arteries that had sustained the advance for nearly a year. Across liberated France, Belgium, and into Western Germany, a network of 1,200 military telegraph lines, carefully laid and maintained by American and British Signal Corps units, began to fail in a single, inexplicable way. Operators at relay stations, listening through their headphones for the familiar rhythm of Morse code, heard only static, a steady, unbroken hiss that carried no dots, no dashes, no messages at all. The lines themselves remained intact. Voltage checks showed power flowing, yet nothing intelligible passed through them. Records from the period suggest this was no ordinary breakdown. The Signal Corps had spent the previous 12 months constructing and rehabilitating thousands of miles of wire across the continent, stringing open pole lines, burying spiral 4 cable, and splicing into damaged French and German PTT systems. By VE Day, the American forces alone had restored or built more than 1,900,000 wire miles of cable and pole line. These telegraph circuits formed the backbone of command and control, secure, reliable, and far less vulnerable to enemy interception than radio. They carried everything from supply orders to intelligence summaries, from casualty reports to the coded updates that coordinated the final push into the Reich. And then, in the space of a few days in late April, this vital subset of 1,200 lines went silent in the most puzzling manner possible. To understand the weight of that silence, one must first return to the world of military communications as it existed in the final year of the war. The United States Army Signal Corps, expanded dramatically since 1942, had become masters of rapid wire deployment. In the wake of D-Day, teams followed the advancing troops with reels of field wire, laying it alongside roads, through hedgerows, and across rivers. Where existing infrastructure survived overhead poles in French villages, underground cables in Belgian cities, they patched and expanded it. British Royal Corps of Signals units worked in parallel, integrating their systems with the American network. The result was a vast, interconnected web that stretched from the Normandy beaches to the Rhine. Historians note that while radio captured public imagination, wire, telegraph, and telephone remained the quiet workhorse. Faster for high-volume traffic, less prone to jamming, and essential when armies paused long enough to establish fixed positions. Lesser-known details from declassified Signal Corps reports reveal the intense pressure on these lines. In the months after the Ardennes offensive, repair crews worked around the clock to restore circuits severed by artillery, sabotage, and retreating German engineers who had deliberately cut cables and destroyed exchanges. By early 1945, the network had stabilized enough to support the rapid Allied advance, yet even in victory, vulnerabilities lingered. Weather, poor insulation on battlefield wire, and lingering electromagnetic interference from nearby radio transmitters were constant concerns. Still, nothing in the training manuals or field manuals prepared operators for what began on April 22. The first signs appeared at a forward relay station near Liège, where a sergeant monitoring traffic to 1st Army headquarters noted that an urgent logistics report had simply stopped mid-transmission. He tapped the key himself. The line responded with clear clicks on his end. But the receiving station reported only static. Within hours, similar complaints arrived from half a dozen other outposts. By the end of the day, the pattern was unmistakable. The affected circuits were not random. They formed a specific cluster, 1,200, dedicated telegraph lines that had been consolidated the previous autumn to handle encrypted traffic between Chi-F forward elements and advancing Corps headquarters. What happened next remains unclear. Initial troubleshooting teams were dispatched, but their preliminary findings only deepened the puzzle. Engineers tested every segment of the lines they could reach. Resistance readings were normal. No breaks, no shorts, no signs of enemy tampering. The static was uniform, persistent, and present even when the lines were disconnected from transmitters at one end. Some operators described it as a low, electric hum that rose and fell like distant surf. Others compared it to the sound of rain on a tin roof. Attempts to bypass the affected segments using alternate routes succeeded only partially. Messages rerouted through radio or secondary wire systems arrived, but the original 1,200 circuits refused to carry anything but noise. And that wasn't the strangest part. What they found next changed the narrative entirely. A careful cross-check of maintenance logs showed that the 1,200 lines had all been upgraded or spliced into the same regional backbone during the winter of 1944-45, when Signal Corps battalions had worked to integrate captured German cable plants near the Belgian-German border. The work had been thorough, documented in meticulous detail by company clerks who noted every splice, every insulator, every test signal sent. Yet now those same lines behaved as though they were tuned to an invisible frequency no one could identify. Some historians believe the static may have stemmed from residual electrical effects of the massive artillery barrages that had pounded the area in the preceding months. Others point to possible geomagnetic disturbances. Records from the time note unusually high sunspot activity in the spring of 1945 that interfered with long-distance radio, though wire lines were thought immune. There is no clear consensus. Personal stories from the men who lived through those days add human texture to the technical mystery. A young lieutenant from the 310th Signal Battalion, whose letters home were later preserved in a family archive, described the growing frustration at headquarters. "We keep sending the same orders over and over," he wrote on April 25, "but all that comes back is this damned hiss. It's as if the war has decided to speak in a language we no longer understand." Another account, from a British signals sergeant attached to 21st Army Group, recalled the eerie quiet in the relay huts, where operators sat with headphones on, waiting for the familiar tap of code that never arrived. The silence was not total. Other parts of the network functioned normally, but the loss of these 1,200 circuits created bottlenecks that threatened to slow the final coordination of surrender negotiations and occupation planning. Multiple perspectives emerged even as the war ended. American engineers suspected subtle sabotage by retreating German units who might have left behind some form of induced interference. British counterparts, drawing on their experience with the French PTT, wondered if local civilian technicians hastily rehired to help maintain the lines had introduced an unknown fault during the rushed repairs of the previous autumn. German records captured after the surrender made no mention of any special operation against Allied telegraphy in that sector. The Wehrmacht's own communication manuals emphasized destruction, not exotic jamming. What happened next remains unclear. With victory declared on May 8, the immediate pressure to resolve the issue eased. The lines were isolated, monitored, and eventually bypassed as the occupation government shifted to newer radio relay systems and emerging teletype technology. Yet the 1,200 circuits were not abandoned. Teams continued to investigate through the summer of 1945, filing reports that grew progressively thinner as resources were redirected toward demobilization. By autumn, the static had become a footnote in after-action summaries, an anomaly noted but never fully explained. The documentation, once voluminous, tapered off, and with it, the search for answers seemed to fade as well. The discovery, when fuller details finally surfaced years later, would wait until long after the men who had listened to that static had returned to civilian life. But in the spring of 1945, as Europe celebrated peace and the last German forces laid down their arms, only one thing was certain. Something essential in the machinery of victory had gone profoundly, inexplicably wrong, and the reason, whatever it was, had been carried away on a tide of white noise. For decades after the guns fell silent, the 1,200 lines remained a quiet anomaly in the official histories of the Signal Corps. The vast documentation of the European campaign after-action reports, technical manuals, and logistical summaries devoted only brief paragraphs to the episode. Most focused on the triumph of rapid wire restoration and the seamless shift to occupation networks rather than the stubborn static that had briefly crippled a key segment. The lines themselves were eventually repurposed, segments cannibalized for other circuits, or left to weather in place as newer technologies took precedence. By the late 1940s, as the Cold War began to reshape communication priorities, the incident seemed destined to fade into obscurity. Yet fragments of evidence persisted in scattered archives. Declassified Signal Corps files from the European Theatre of Operations contain test logs from the spring and summer of 1945. Technicians had methodically isolated sections of the affected circuits, measuring resistance, capacitance, and induced voltages. The static persisted even when entire stretches were disconnected from power sources at both ends. Some reports noted faint, rhythmic variations in the noise that appeared to correlate with time of day, though the pattern was never conclusively mapped. What happened next remains unclear. No single document declares the problem solved. Instead, the entries simply grow fewer as attention turned elsewhere. The development of the mystery unfolded slowly in the post-war years. As occupation forces settled into Germany, the need for those specific telegraph circuits diminished. Radio relay systems, already proven effective during the rapid advances of 1944-45, expanded rapidly. VHF and HF links provided redundancy that made the silent wire lines less critical. Still, a small team of engineers continued periodic monitoring into 1946. Their notes describe attempts to filter the static using experimental equipment borrowed from laboratory settings. Results were inconclusive. Some engineers speculated that the noise originated from induced currents caused by the enormous quantities of metal debris, shell casings, vehicle wreckage, and abandoned equipment littering the battlefields through which the lines ran. Others pointed to the integration of captured German cable plants, whose insulation and grounding techniques differed from Allied standards. There is no clear consensus. Personal stories from the signals personnel add layers of quiet frustration and quiet wonder. A corporal assigned to a relay station near Aachen kept a pocket diary that survived in his family's possession. In entries from late April 1945, he described the operator's growing unease as urgent messages about prisoner movements and supply convoys failed to transmit. "We can hear the war ending on the radio," he wrote, "but our own lines speak only in whispers of nothing." Another account, from a British signals officer attached to the combined network, recalled the strange atmosphere in the huts. Men hunched over keys and receivers, listening to a sound that seemed almost alive, rising and falling like breath. These individual testimonies, collected years later in veterans' oral histories, reveal how the technical failure carried an emotional weight, reminding soldiers that even in victory, control over events remained partial. Multiple perspectives emerged among the experts who reviewed the case in the immediate post-war period. American Signal Corps officers tended to attribute the issue to the cumulative stresses of battlefield conditions. Rapid laying under fire, hasty splicing, and exposure to the electromagnetic environment of a continent at war. British counterparts, with deeper experience in rehabilitating European civilian systems, wondered whether subtle differences in soil conductivity or lingering effects from massive artillery barrages had created unexpected ground loops. Captured German technical personnel, interrogated about communication infrastructure, offered no specific insight. Their own systems had relied heavily on similar wire networks, which they had often destroyed rather than sabotaged in exotic ways. And that wasn't the strangest part. Evidence layers accumulated slowly as researchers revisited the records in the 1950s and 1960s. Meteorological logs from the period document heightened solar activity in the spring of 1945, with increased sunspot counts noted by observatories in Europe and the United States. Geomagnetic disturbances, known to induce currents in long conductors, had historically affected telegraph lines, most famously in the 19th century during major solar storms. Some historians believe a similar, milder phenomenon may have played a role here, especially given the length and orientation of the affected circuits across northern Europe. Yet wire lines were generally considered far less susceptible than long-distance radio or submarine cables. The static's uniformity and persistence, even on isolated segments, did not perfectly match known geomagnetic effects. What they found next changed the narrative entirely for those who dug deeper. In the 1970s, as declassification waves opened more Signal Corps technical files, a small group of communications historians cross-referenced the 1,945 logs with contemporaneous reports of atmospheric conditions and equipment performance. They discovered that the 1,200 lines shared a common characteristic. All had been routed, at least in part, through areas heavily contested during the Battle of the Bulge and the subsequent push to the Rhine. These zones had seen intense concentrations of artillery fire, tank battles, and the deployment of large numbers of electrical systems generators, vehicle ignitions, and even early electronic warfare devices. Soil samples taken decades later in some sectors still showed elevated metallic content from shrapnel and unexploded ordnance. Could this have created a vast, unintended antenna or resonator effect? The idea remained speculative. Records suggest the engineers considered environmental induction, but lacked the tools to measure it definitively at the time. Escalation in interest came during the 1980s and 1990s with the digitization of military archives and the rise of academic studies on wartime technology. Scholars examining the broader transition from wire to wireless communications noted how the 1945 incident highlighted the limits of even the most robust physical infrastructure. The lines had performed flawlessly through the harshest combat phases, only to falter as peace approached. Personal correspondence from senior Signal Corps officers, now available in presidential libraries, reveals private acknowledgements that the anomaly had caused minor delays in occupation planning, but never threatened overall command. One general wrote to a colleague that the static served as a reminder that nature and war leave their marks in ways we cannot always predict or repair. A turning point arrived in the early 2000s when a collaborative project between U.S. and European historians re-examined surviving segments of the old network. Using modern electromagnetic sensing equipment, teams conducted non-invasive tests along former route corridors in Belgium and Western Germany. They detected faint residual anomalies, localized magnetic variations consistent with disturbed soil and buried metallic debris, but nothing that fully replicated the 1945 static. The findings added weight to the idea of cumulative environmental interference, while underscoring how much had changed in communications technology. Fiber optics and satellite links had long since rendered those old telegraph circuits obsolete. Yet the collapse of sustained investigation followed soon after. As Cold War archives took priority and funding shifted toward digital history projects, the 1,200-line episode receded once more into specialized footnotes. Some segments of the original cable were excavated during infrastructure projects in the 2010s, their insulation brittle and cracked after 70 years underground. No new explanatory documents emerged. The physical evidence, like the paper records before it, offered confirmation of the failure but no definitive cause. In the aftermath, the story of the silent lines serves as a quiet illustration of the complexities of technological systems under extreme conditions. The Signal Corps had achieved remarkable feats laying and maintaining vast networks across a devastated continent, yet even their success contained this unexplained pause. Some see it as evidence of the unpredictable interplay between human engineering and the natural environment, particularly in the closing days of a war that had scarred the land and the atmosphere alike. Others view it as a footnote in the larger shift away from vulnerable physical wires toward more flexible, if sometimes equally temperamental, radio and electronic systems. Modern re-examination, aided by advances in signal processing and historical data analysis, has revisited the possibility of solar or geomagnetic influences. Sunspot records from 1945 confirm elevated activity, and contemporary studies of space weather have deepened understanding of how such events can induce currents in conductors. However, the precise alignment with only those 1,200 circuits and the static's behavior on isolated sections continues to resist easy explanation. Proposals for further archival dives or targeted field measurements surface occasionally in academic conferences, but comprehensive reinvestigation has not yet occurred. The 1,200 telegraph lines that carried only static in the spring of 1945 remain a testament to the limits of certainty in even the most documented periods of history. They functioned brilliantly when most needed, then fell silent without clear reason as victory dawned. Their story, preserved in fragments of logs, letters, and fading recollections, invites reflection on the invisible forces, environmental, technical, and human, that shape the machinery of war and peace. Wherever the final answers lie, if they exist at all, the lines themselves have long since gone quiet, leaving behind only the echo of that persistent, unexplained hiss.